Cool. Thanks for inviting me. It's good to be here, everyone. How's everyone doing tonight? Good? Filled up with pizza and beer soon. Adrian told me that most of you are sort of at the intersection of like data science, infrastructure, DevOps, software engineering. Is that roughly correct? I'm seeing lots of heads nod.
Everybody nod. I will feel very bad if I have.
Yeah, unless that was a completely inaccurate representation. So it's really cool to be here. I'm from San Francisco in the Bay Area. I don't do too many talks, but thought it would be really cool to start to talk publicly about some of the things we're working on these days. And I guess maybe just as a quick intro on myself, I've spent sort of the last 4 years around the Kubernetes project. I was fortunate enough to be working at Mesosphere when Kubernetes was released, and got to know a lot of people kind of in the project in the very early days. Started the first company around Kubernetes, a company called Kismatic. We were sort of kind of Heptio 0.1. I think Heptio reference is maybe relevant since we're in Seattle here. I think they're just up the street. Services support training kind of for Kubernetes, helped a lot of people learn about Kubernetes, and I also started a conference around Kubernetes, KubeCon, which is now run by the Linux Foundation, CNCF, the group that Luke's a part of.
It'll be here in December.
Yeah, that's right.
So like tomorrow, practically.
Yeah, right around the corner. The third North American KubeCon is going to be here again in Seattle. I think the second one was here in Seattle last year as well, except this one's going to be a lot bigger. I think it's something around 6,000 or so people.
They estimate 6,000.
7,000 people.
4,000.
Yeah.
Before that was 800, and it's just.
So Kubernetes is kind of taken over the world. CNCF's done an amazing job kind of running the event. They have an incredible world-class support staff events team. Kind of Kubernetes has been really central to my life, I guess, over the last several years. The most recent two things that I've been working on are my current startup, the second startup I've been working on, which is called Aljabber, and we're working on data pipeline infrastructure built on Kubernetes and sort of rethinking the way you can unify streaming and batch processing applied to machine learning data pipelines and just general purpose data processing infrastructure. And very recently, a couple months ago, I started a new type of venture firm, kind of accidentally, unintentionally. Didn't wake up one day a year ago and say, I'm going to do this. But 2018 in particular has been sort of the most profound year for this kind of category I'm calling sort of commercial open source software companies. Sort of every month or so this year, we've seen a pretty large commercial open source company outcome of some kind, whether it's an IPO or a merger and acquisition event or a private equity event of some kind. And obviously, Red Hat announced they're joining IBM over the weekend. So pretty amazing year for open source. So I guess as far as the AMA thing, I'm happy to talk about Kubernetes. I'm happy to talk about open source funding in general. It's a topic I'm pretty passionate about, have been for probably close to 10 years. Kubernetes is kind of eating the infrastructure world in a big way. There's another really exciting company here in Seattle focused on kind of multi-cloud Kubernetes infrastructure. The Upbound folks, and Bassam's back there from Upbound. I think Upbound's just up the street. So lots of really awesome, there's Pulumi here in Seattle area. There's lots of really cool, obviously Heptio, Kubernetes startups, infrastructure companies. I'm happy to take any questions if anyone has any sort of thing that you're sort of thinking about as far as how does Kubernetes like impact what you're doing on a day-to-day basis? How does it affect the sort of future of different projects you might be working on? As one dimension, sort of I can talk pretty extensively about Kubernetes. On the other side of things that I'm working on, open source funding, I think, is a pretty polarizing, complex topic, and there's lots of different opinions.
With when you look at a traditional startup, if that can even be called a thing, really, but a startup, a VC firm would go in and look at like, all right, what's the leadership, what's the product, what are they doing, what's the outlook in the future? There's certain things they look for.
Yep.
What's different, especially technically, looking at an open source company or a company that's prospectively going to be doing open source?
Yeah, this is a really big question. So I've kind of been repeating this conviction over the last several months probably, but I think it's something that I've always felt, which is that commercial open source software companies are fundamentally different in almost every way functionally, so by function in those companies, as compared to proprietary closed source software companies. And I think you can make a distinction kind of in both areas, where commercial open source software companies can be defined as fundamentally depending on an open source project to justify their existence. So like GitHub wouldn't exist without Git, Cloudera wouldn't exist without Hadoop, Elastic wouldn't exist without Elasticsearch, DataStax wouldn't exist without Cassandra, and so on and so on. And then proprietary software, closed source software companies sort of have like a top to bottom proprietary closed source intellectual property stack of some kind, and they go to market and they kind of commercialize that product in sort of fundamentally different ways than a commercial open source software company would go to market or distribute their product. Product actually has a different meaning even in commercial open source software companies. So I'm just of the belief that kind of everything is fundamentally different. And so you could sort of like segment out those companies to be sort of fundamentally distinct. On a technical level, how are they different? I think starts with they're very developer-centric.
Yeah.
So a traditional proprietary software company, even if it has a free version of a product and it's like completely free to use and like developers might use it, with a commercial open source software company, you almost don't start with the company. You start with the project. And the project then gradually like bleeds into the company.
Yeah.
Whereas with a closed source proprietary software company, you really do start with a product. And you have to like spend all this energy, in fact, from sort of like energy joule 0.001 onward to get anyone to use your product. Whereas with an open source project, you can literally flip the switch on a repository and have someone in Zimbabwe using your thing when you wake up without spending any energy other than flipping the switch on the repo. And that has an exponential effect. So I think they're just two fundamentally different types of companies. And then the sort of dynamics on both sides manifest in the different functional areas fundamentally differently as well in terms of business model and product and engineering and culture, strategy, marketing, product, sales, everything functionally, finance even. Faye's question is, what am I working on in the sort of data pipeline area as it relates to Kubernetes? How is it different from Kafka? So I guess I'll start with the question, how many of you have heard of Apache, the Apache software project, Apache Beam? Apache Beam? Wow, that's impressive. This is the most hands I've ever seen go up. That was at least 5 hands. Very cool. Okay, how many people have heard of Kafka, Apache Kafka? More hands, almost everyone. Oh, the phone knows. The phone has heard of Kafka. What about TensorFlow? Who's heard of TensorFlow? Okay, so I'll sort of give you a high-level answer and then it can get maybe a deeper answer. And feel free to reach out to me. I'm happy to go a lot deeper. So today, people are building different data pipelines based on different types of patterns and sort of workflows. So some data pipelines are very real-time centric and streaming centric. So you're taking in data from like click streams or log data or some fast-moving source that is sort of funneling the sort of changes to the data into some kind of real-time online pipeline. And you might be using some publish-subscribe mechanism or some streaming queue or some message bus or something to process all that information and do transformations and manipulations against the data. Whereas other types of pipelines are very batch offline-centric. So you're taking in some files or you're taking in some chunks of data from some data warehouse or something, and then you're running batch operations, batch pipelines. So there's two different types of, fundamentally different types of data processing workload. With Apache Beam, the reason I asked about Apache Beam is Apache Beam has an interesting model where it sort of fuses and combines the two types of paradigms in one architecture. And this architecture is called the data flow model or data flow architecture. It's a sort of semantic or an approach to data processing as a paradigm that Google wrote about a few years ago, and they had a paper published on that. Apache Beam is an open source software implementation of the data flow model. And data flow basically says that you can take as input to a pipeline real-time or batch sources of data, but you really treat everything as a stream of data. But in order to do batch processing on it, you just kind of window, or you have what's called a bounded snapshot or a context, a bounded sort of snapshot of that data, and then you run transformations against sort of a window in time of a stream of events coming into a pipeline. But data flow or the Beam model basically says that everything is a data stream. Everything is a real-time kind of event stream coming into something, like the data flow pipeline. What the Beam project then does is, after you have your data coming into that data pipeline, you construct a directed graph of the pipeline itself and all the steps in the pipeline and what you want to do in terms of transformation and all the different processing logic in that pipeline. But what Beam allows you to do is, in each step of the data pipeline, you can actually activate or you can invoke a different data processing backend or different data processing technology. So in one step of a Beam DAG pipeline, you could be doing some processing in Kafka, and then the output from that data in Kafka, using some type of transformation function in Kafka or some publish-subscribe transformation, could then go into another step in the Beam model, which could be doing something in maybe TensorFlow. And then the output from that, after running some machine learning inferencing on that data, could be running into another step in the DAG, which could be something in Apache Spark, for example. So each of these data processing backends have different ways of manipulating real-time or batch data. And Beam sort of lets you mix and match those different backends. What we've been working on is a way to sort of simplify that general architecture, that general paradigm, on more modern, extensible primitives like Kubernetes. So we're sort of taking some inspiration from this data flow paper, this data flow model, as well as the Apache Beam project, and looking at improving and simplifying that for many more different types of data pipelines, basically. Commercial open source projects. So your question was the different commercial open source projects that we've seen, which ones succeed, which ones fail, and why do they succeed, why do they fail?
Yeah, basically, like if you look at startups in general, I think people kind of have a sense of what makes a good startup, what makes a bad startup. Are there things about sort of the commercial open source movement that are starting to kind of coalesce? That's
interesting. Yeah, I mean, I think that there are. So I guess the question was, what was your name?
Dylan.
Dylan. So Dylan's question was, what are some patterns of success or failure in commercial open source software projects, but also companies?
Yes.
More companies?
Both.
Both.
The other, whichever you think you can.
Interesting. So I'll focus on companies then. So I think that there are some interesting patterns. So I've been kind of maintaining this little spreadsheet, which has grown into a bigger spreadsheet. It's called the Commercial Open Source Software Company Index. It's kind of like an S&P 500 index, but specifically for commercial open source software companies. And I have like a criteria of, like a revenue criteria for that index, kind of like how S&P 500 is like the big higher chip index of large companies. There's definitely a lot of data around what makes a very successful commercial open source software company, where the definition of success is, multi-billion-dollar company with hundreds of people, and it's growing, and it can go public, or it can have a large outcome, and so on, compared to less successful or companies that aren't able to reach that size or scale. this is a really complex topic, and I have tons of opinions here. I could probably talk for several hours. I'll give you the super short. I think that it's important for a software project, the open source project the company is based on, to be very well positioned in an area that companies are accustomed to or conditioned to paying for commercial sort of features or sort of enterprisey features, if you will. So if you're selling into an enterprise and you have a wildly successful JavaScript library, and that JavaScript library has millions of users, but you go into IT, corporate IT, the CIO's office, and you say, hey, here's my enterprise JavaScript library plus. I think that there's a very low probability you'll be able to sell, product based on your enterprise JavaScript library plus product. However, if you sell enterprise version of Elasticsearch, this is actually sort of a database where you store and index your data and you query it. It's actually like a source of truth and it's mission critical and so on. And companies are going to be writing and reading really important, sensitive, valuable data from this database. And they also happen to be conditioned to pay for production database-oriented software like Cassandra, for example, and DataStax Enterprise has sort of a hardened production version of Cassandra. I think you'll have a higher likelihood of being able to build a business in a commercial company around something like something closer to a database. I have a more abstract philosophy and way of looking at this, which is that if you have an open source project that is close to two sort of abstract layers in sort of a technology stack, like one where you're doing reading and writing of data, sort of the persistence tier data path, and then another tier where you're doing sort of proxying of data, like the network tier or the proxy tier data path, sort of think Cisco switches and then think Oracle database kind of style layers. If your open source project sort of sits on top of either of those layers or close to them, that's a very abstract way of looking at it, but it's just at least a high level initial framework. You're more likely to potentially be able to build business around your project. That could potentially be like a large-scale business. Yeah, but that's a pretty nuanced, complex area of conversation. Yep. Yep.
You said earlier that with open source companies, the kind of project led into the company.
Yep.
That kind of implies that companies that form around open source projects are kind of post-market fit or post-product.
Oh, interesting.
What does it look like for early stage or pre-product companies? Is there space for that in terms of funding or what does it look like?
Well, that's fascinating. So your question was, so there are two types of product market fit stage companies that are formed around open source projects that have quite a lot of adoption and maybe validation in the usage, and then companies that are formed around open source projects that are much earlier on in their adoption, where you don't really see maybe a project market fit as opposed to product market fit.
I like that.
Yeah. So I think I would call it project market fit.
Okay.
I think that's a really interesting question. There's probably examples on both sides where you could build very successful companies. I think the very large and successful, well, I think there's actually examples on both sides. There's examples of companies that have succeeded and built large billion-dollar businesses where the company, well, I would actually look at it abstractly like the company was started when the project was started. And then there's a few examples that I can think of just off the top of my head where those companies actually were built long enough to become large businesses. And then there's also many examples of where a company was formed around a project that had already been in existence for several years, getting lots of adoption. The company was formed and then also was able to build a large business. So I'm not dogmatic about either approach. I think both approaches are probably valid. It's certainly tempting to sort of only support and say from the perspective of OSS Capital, invest in companies that are formed after projects have gotten a lot of validation from end users and developers and so on. I think that some of the best companies, though, that are of early stage but also large, were actually formed when the projects were like very nascent, maybe months old, weeks old, maybe even created as the company was created.
I mean, what does funding look like that's equivalent to like seed capital, I guess, in terms of process capital? Like, what would that look like? Is it even possible for these kind of companies?
For which category? So either category, or?
I mean, say in traditional venture, a team might go and look for early stage investment, and they haven't built anything, or they built a prototype. Like, what would that look like, if at all?
Yeah, that's a huge question. I mean, I think so. The question was, what is the investing analysis or just sort of decision calculus look like on either side? Like early stage, open source founding team, starting the company with the project that's very, very early or is just starting to be created, or a project that has lots of adoption and validation and signal, and then a company. I think that every team is kind of considered, evaluated a little bit differently. Traditionally, I think in the sort of current venture capital approach, because our approach is pretty differentiated and different, we sort of take a very pure and focused way of looking at open source, commercial open source companies. But I would comment, because I've started 2 companies, I've raised money for both, and they're both open source kind of companies. Traditional kind of investors, and there are quite a lot of smart, knowledgeable, open source experienced investors, commercial open source experienced investors, but I think traditionally venture capitalists very, very frequently optimize for mitigating risk and reducing risk around the team as a really, really important factor. The market opportunity, what they can see here and now as things to be sort of disrupted or disintermediated or spaces to create. And then finally, the technology and the implementation of things. Whereas, for us, all those things are also important, but we just exclusively focus on the world and the spectrum of things that could be commercial open source businesses, commercial open source software businesses, and we don't really have the sort of, distraction of also trying to generalize a decisioning model across many spaces. So we just go very, very deep on commercial open source, and there's a way of looking at and evaluating teams that have a project that's a week old, as opposed to teams that have a project that is a year and a half old with 50,000 stars and 20 million users and 25 enterprise customers going through POCs and so on. Obviously, you'd evaluate and value those things a little bit differently. It doesn't necessarily mean the risk profile is different. So it's kind of case by case still. But I would just say generally that our belief is if you can have a really high degree of focus and just do one thing really well, you can probably be more successful.
Yeah, I'm interested in the technology you used in the data pipeline
Mm-hmm.
in terms of like, are you using the stateful set or any other, I don't know, nuke or anything like that?
It's a really, really good question. So the question was, are we using stateful sets or Kubernetes primitives like in the API, like the default controllers maybe when we're building our data pipeline project and infrastructure? We're actually using a lot of extensibility primitives in the Kubernetes API, so things like custom resource definitions and custom controllers. So these kind of things called operators, custom Kubernetes operators, which are like application-specific controllers to sort of automate the way you would run. So for example, with something like Cassandra, the way you would package and run Cassandra as a native Kubernetes workload or service, and where that Cassandra service has its own custom APIs in the Kubernetes API server, and then you sort of like manage the lifecycle of those APIs through a custom controller binary as well, and the logic in that custom controller would basically codify the way Cassandra should be operated and run on a Kubernetes cluster. We take that pattern and we use that pattern for different data processing dependencies that we rely on for our data pipeline engine. So we're really big believers in custom Kubernetes APIs.
I see. So all the data are stored on inside the Kubernetes, right?
Correct. Yeah, both the data processing. So the clarifying question was the data itself is stored in Kubernetes. That's true. We also run those services natively on Kubernetes. So they're not running outside of Kubernetes. They're running directly on the Kubernetes cluster. And of course, like Cassandra persisting storage directly on the Kubernetes cluster, as well as all the data pipeline infrastructure is running there as well.
So Luke and I was chatting a little earlier in the day, that primarily kind of from the Kubernetes viewpoint, but a lot of open source projects. They're not super easy to get started with. They don't have a good, clean developer workflow. You gotta get them and then just beat on them and pry them and hack at them and figure all this stuff out. Do you see many companies, especially in the OSS realm, that are working to make the developer flow smoother, easier, etc.?
Yeah, I think there's a lot of, so the question was, are there companies working on improving the developer workflow for Kubernetes in sort of all the different tools and systems you need to integrate to actually build a production service? Like, you've got to pull in your tracing library and your data processing layer and your monitoring and logging stack and your container runtime and your networking stack, and it's like 16 different components you've got to like compile up. I think this is a really exciting active area of development in the Kubernetes project itself, as well as more broadly speaking in the Kubernetes ecosystem in terms of startups and vendors. If you take a look at the cloud native computing landscape, there's a big maze of projects and companies that are working on simplifying the way you can push code from source repository and materialize it as a service on Kubernetes through to compiling up application stacks and deploying them as Helm charts or operators, simplifying the way you can kind of integrate different services. There's companies like Weaveworks that have more of an opinionated Git push sort of workflow with sort of a streamlined way of pushing out your software through to production in different sort of kind of templatized, packaged, customized ways, but with sort of opinionated primitives and things that sort of are handled for you and pre-configured. There's obviously, I mean, that's maybe a generous way of putting it. I think the software delivery lifecycle is so snowflakey. Every company does it differently. It's really hard to reproduce, and it's sort of like a star schema. If you look in,
you just made me think like Ruby on Rails, Kubernetes.
Yeah, I mean, I think this is an interesting area. It's just, personally, I don't think anyone will agree on a common software delivery model. Right. I think we can agree on packaging, which is why Docker is really powerful. Yeah. I think we can agree on like a distributed systems API, which is why Kubernetes is starting to become really successful. I do not think, this is just my own opinion, I could be wrong, and maybe that's a little contrarian, I do not think we'll ever agree as an industry on what an SDLC software delivery kind of opinionated, captured sort of standard model will look like, because every company wants to push out their software differently. And it's for that reason that I think companies like HashiCorp and GitLab are really successful, because GitLab gives you kind of a custom, tailored, configurable, extensible way to push your software out across a sort of automated delivery pipeline, but where you can choose your own defaults and sort of customize that pipeline. HashiCorp lets you heterogeneously configure and sort of modernize your infrastructure in a composable way, as opposed to saying, I've got a full stack rethink of something and then I've got to move to some platform as a service. Right. Cloud providers also interestingly let you do that by letting you pick and choose which services you want to use. So they do that with sort of like a subliminal approach. Sort of like, pick what you want, just use S3, and then all of a sudden you get sucked into using 9 other services without really knowing it. But that's really what works, because infrastructure is very complex and heterogeneous. And I think infrastructure is inherently snowflakey, and I don't think that's going to change. But lots of innovation around standardizing the way you can package and configure different services on Kubernetes. And there's the service broker effort, there's Helm charts, there's operators. The team over at Upbound in town here are working on some really awesome things around being able to abstract away the idea of a cloud provider into the experience that you get from Kubernetes, which I think is a powerful way of looking at things. So lots of innovation there for sure. It's a complex area. Kubernetes is a pretty low-level API. kind of like almost like the Linux kernel, sort of, as far as the primitives that it exposes. But I think over time, we're going to have more agreement on what it means to deploy an application on Kubernetes and what the dependencies of an application are and that sort of thing.
I'm very curious to see where this KubeCon in a few weeks takes that conversation too. Because in Austin, like, that was one of the prominent conversations across presentations and the keynote. They brought that up. I mean, you had everybody from Brendan Burns to Kelsey Hightower talking about the developer doesn't need to fiddle around with kubectl, whatever the command is called.
Right.
And, you know, they need to be able to build business use case.
Right.
They need to get something to the customer, not fiddle with like the knobs on
Right.
the back end. So I'm very curious myself, having been for a long time the person trying to build something for the customer. I love all the back end stuff. I love nerding out on it, building all sorts of big systems. But at the end of the day, I mean, somebody's going to want me to build something, so I'm curious.
Right.
How do I get that done better?
And I think that's the journey everyone's on.
Yeah.
So it's going to be really exciting to see. KubeCon this year in Seattle is going to be enormous. I think there's going to be lots of really cool announcements, and I wouldn't expect anything conclusive or binary. I think it's just going to be more innovation, more tooling, more awesome approaches to things, and definitely more end users. There's going to be just like huge companies. You're going to hear about some of the biggest technology internet companies in the world standardizing everything on Kubernetes, and it's really incredible to see how fast that's happened for such a young piece of technology. It's only 4 years old.
Yeah. Young piece of technology with old companies.
With old companies, yeah, that's very true.
Yeah.
Serving for data intake over from IBM to, I saw your comments on your Twitter.
Oh, okay.
So can you elaborate a little bit, like in terms of how does it benefits the Kubernetes community in terms of OpenShift?
Question was, what's my extended elaborated take on the IBM takeover of Red Hat?
Right.
In the context of Kubernetes and OpenShift. And so I think the first thought that came to me about, like, after filtering through hundreds of the comments and stuff about like the initial response of like, oh, this is bad for Red Hat and it's bad for open source and they're just going to get extinguished, or IBM's trying to compete with Amazon more effectively and this whole hybrid cloud thing. Personally, I think this whole acquisition is about IBM becoming an open source company. Full stop. Like, that's what it's about. The biggest technology companies in the world are trying to become open source software companies because open source software is the future. Developers are increasingly defining what the future looks like, and the number one tool that developers use is open source software. And so I think that's kind of the way I look at it. So that my tweet was sort of like, oh, IBM is not buying Red Hat to dominate the cloud. It's really about IBM becoming an open source software company, and to become an open source software company, acquiring Red Hat moves them much further along in that direction. Whether or not they realize that, I think, is actually an interesting question. But I think that that's probably the best way of leveraging that acquisition, which they're having to increase a huge amount of debt to pull off. And so I think it's also a positive thing for Kubernetes and for OpenShift and for the Kubernetes ecosystem. Red Hat has poured probably a few $100 million into Kubernetes development from the beginning. They were the second biggest corporate sponsor contributor to Kubernetes when Kubernetes was released. Brian Stevens, the CTO of Red Hat then, and Clayton Coleman, who was like staff engineer, principal architect at Red Hat, had been from the very beginning very deeply involved in the Kubernetes project. So I think it's positive. I think it's positive overall. I think it's a huge sign that open source software is transforming the largest technology companies on Earth. So we saw, Microsoft is really communicating like it's critical and important for them to be the world's #1 biggest open source software company. Like, that is really shocking. Like, let's move past Microsoft embracing Linux. Like, Microsoft saying that they're the biggest open source software company is, like, 5 years ago, oxymoronic. I mean, they're the world's largest proprietary software company. That's what they really are. And yet they're saying they want to be fully open source. They're actually demonstrating some huge things. They open sourced all of their patents. A couple of weeks ago they announced that. That's really earth-shatteringly huge news. Acquiring GitHub is also a big commitment in that direction. And the fact that they're embracing Linux and embracing Kubernetes, Microsoft's a huge Kubernetes contributor. That's a really big deal. I think IBM's really smart to have made that acquisition. I think Cisco, Alphabet, Google, Microsoft as well would have been really smart to buy Red Hat, but IBM made it happen. So those are my thoughts. And I think open source software is eating the world. It's eating everything really beyond the world. Mark Andreessen likes to say software is eating the world. I really think that open source software is eating software, is eating the world, and it's eating everything else. So I think that's kind of a great future, great time to be alive. So developers, keep writing open source software, and let's keep cheering for open source.
Cool.
Thanks guys for having me.